So how am I transmitting the signal number 1? If I want to ask that question, the signal number 1 is transmitted in the form of all these red samples. And in between the samples of signal number 1, what do we have? So we have samples coming from other signals in that case. How are we transmitting signal number 2? For signal number 2, we are transmitting it also in the form of samples. And in between two samples of the same signal, we have samples coming from other signals. So in simple words, what are we doing in this case? In this case, we are dividing the time axis. So what are we basically doing is in first small slot, we are transmitting sample of the first signal. In the next slot, I'm transmitting sample of the second signal. And likewise, in the last slot, I'm transmitting signal from the last sample from the last signal. What will come after the last slot? After the last slot will again come the slot for the transmission of the sample from the first signal. So this one whole thing is called one time frame. And in one time frame, we transmit samples from all the signals. So after one time frame gets over, the next time frame starts, and we will transmit all the same the samples from all the same signals that we have. So after this first red time slot, the next will be blue time slot, and likewise the last time slot will be the green time slot. So likewise, you can see we will have frame number 1, frame number 2, and so on. So we have time frames, and every frame contains samples from each and every signal. If you have observed carefully, time division multiplexing, we do not transmit signal continuously. We transmit signal in the form of samples, and hence we will have to consider sampling process and sampling theorem for the proper transmission of all the signals. The Nyquist sampling theorem says that for the transmission of signals in its sampled form and for its recovery on the receiver side, the sampling frequency Fs has to be greater than equal to twice Fm, where Fm is nothing but bandwidth of that particular signal. So when we take these samples, we have to make sure that the switching is taking place such that we are going to read the required number of samples in 1 second. In 1 second, there will be multiple time frames, and in each time frame there will be one sample from one signal. So in 1 second, we have to ensure that we read enough number of time frames such that from every signal we are taking number of samples given by this sampling frequency Fs. It has to be minimum equal to twice Fm. If the switching is slower compared to the sampling rate that we require, then I will be transmitting lesser samples, and on the receiver side the recovery may not be possible. Now let us see what happens on the receiver side. On the receiver side, we have a similar switch. This switch is called decommutator on the receiver side. What will decommutator do? When the switch on the transmitter side is connected to a first input channel, the switch on the decommutator, that means the receiver side, will be connected to the first receiver channel. So the sample that comes from the first input channel goes to the first output channel. When the switch is connected to the second input channel, then the switch on the receiver side should be connected to the second output channel. In simple words, what I'm saying is there has to be perfect synchronization between commutator and decommutator. So by having that synchronization, we can make sure that the separation of signals takes place on the receiver side. So on the receiver side, what will you receive is you will receive all the samples coming from the first signal on the first output channel, all the signals coming from second signal to the second output channel, and similarly all the samples coming from last input channel to the last output channel. And we will receive samples of the signals, and hence we will have to pass this sample through the low pass filter as we had seen in the sampling process. Once you pass this through low pass filter, we will be able to achieve the smooth or the continuous signal which will resemble to the original signals that we had. So that's the time division multiplexing system. Let us look at a proper block diagram, and then we will discuss the bandwidth requirements. Please remember that we are not dividing the frequency slot. we are dividing the time slot in this case. So in simple words, I can say that when signal number 1 is transmitting, it is the only signal I'm transmitting and no other signal I'm transmitting. So signal number 1 can utilize the entire channel bandwidth which is available. In the next time instant, signal number 2 is being transmitted and hence it can also utilize the entire channel bandwidth. So I can utilize the entire channel bandwidth for the transmission, unlike in FDM where I have to use only the frequency slot.